Learning objectives. At the end of this topic, you will be able to understand about flame and its structure for different materials, discuss about fuel and its efficiency, list out the harmful effects of burning fuel, observe an LPG flame. Can you tell the color of the flame? What is the color of a candle flame?
It's yellow golden.
Right. Can you tell me whether the burning of material is flame or not?
I don't know.
Okay, I will tell you about flame. This will be helpful to you. Let me begin my chapter. The substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Charcoal, on the other hand, does not vaporize and so does not produce a flame. Let's perform an activity. Light a candle and hold a glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. When the candle flame is steady, introduce a clean glass plate or slide into the luminous zone of the flame. Hold it there with a pair of tongs for about 10 seconds. Then remove it. A circular blackish ring is formed on the glass plate or slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Hold a thin, long copper wire just inside the flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. In fact, this part of the flame is the hottest part. Goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. The sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. A good fuel is one which is readily available. It is cheap. It burns easily in air at a moderate rate. It produces a large amount of heat. It does not leave behind any undesirable substances. There's probably no fuel that could be considered as an ideal fuel. We should look for a fuel which fulfills most of the requirements for a particular use. Fuels differ in their cost. Some fuels are cheaper than others. We can group fuels as solid, liquid, and gaseous fuels as in the table. The amount of heat energy produced on complete combustion of 1 kilogram of a fuel is called its calorific value. The calorific value of a fuel is expressed in a unit called kilojoule per kilogram. Calorific values of some fuels are given. The increasing fuel consumption has harmful effects on the environment. Let's discuss about each one of them. Carbon fuels like wood, coal, petroleum release unburnt carbon particles. These fine particles are dangerous pollutants causing respiratory diseases such as asthma. Incomplete combustion of these fuels gives carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill persons sleeping in that room. Combustion of most fuels releases carbon dioxide in the environment. Increased concentration of carbon dioxide in the air is believed to cause global warming. Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rainwater and form acids. Such rain is called acid rain. It's very harmful for crops, buildings, and soils. Summary. Let's summarize the topic. The substance which vaporizes during burning gives flames. Fuels are the sources of heat energy for domestic and industrial purposes. Fuels can be categorized into solid, liquid and gaseous fuels. Calorific value is the amount of heat energy produced on complete combustion of 1 kilogram of fuel.